Okay, so in the last lesson of this chapter, I'm going to be going over how we differentiate the inverse trig functions, and then I'm going to go over some real life application problems where you can see how we use them and practice some of the ways you'll see them probably on your AP exam. So let's look at a review first of their graphs and how we can solve inverse trig equations, because I know it may be a while since you've seen this stuff from pre-cal or algebra 2, but remember that another way to write the inverse of sine or cosine or tangent and so forth is writing the arc sine. So this is the same as saying y is equal to the inverse sine of x. You know, like it's not sine to the -1 power. Again, this is inverse sine of x, but again, you may see it as arc sine of x in like your textbook. Same thing though. So here are the graphs. We got the graph of the arc sine of x, the arc cosine of x, arc tangent of x, the arc cosecant of x, the arc secant of x, and the arc cotangent of x. Now, the initial thought that usually comes to mind is like why do the graphs look so weird? Why aren't they like, why don't they keep on going like up and up, or why don't they keep on repeating like the trig functions? Why do they stop? Like, why are they cut off at those points? And if you remember from lesson 3 in this chapter, where I went over how we differentiate inverse functions in general, the first thing you need to make sure is that the function itself has an inverse function, meaning that it's 1-to-1, and that way the inverse function will also be a function. Okay, so what do I mean by that? Remember that if we remember the sine of x, let me just draw a little sketch to the side here of what the sine of x function would be. It would look like this. We know it's like a repeating, oscillating, periodic function. It goes up, down, up, down, up, down. So the initial thought is like, well, if this is the sine of x, let me write y is the sine of x. Then, following that pattern, it would be doing this. It would go like that. But if it did that, this graph would no longer be a function of x, because there would be multiple points that violate the vertical line test. So for this example, an x value of 0 would be here, and it would give you a y value of 0. But this point also has an x value of 0, and it gives you a different y value. And this point also has an x value of 0, and it gives you even a different point. So this, would just go on forever, and you would have like an infinite number of y values for the same x value of 0. And you can basically apply that to any point or any x value on the graph. So that's why we have to cut it here. We have to restrict the domain, because after this point, it would start having repeating y values. So that general idea is applied for all the other trig functions. So that's really all there is to it. Let's go over now how we evaluate the inverse trig function and how we can solve these equations. Okay, so we want to find first the arc sine of -1/2. Another way to look at this is to solve the equation where you have the sine of x is equal to -1/2. Because remember, the inverse function is kind of like going backwards from the regular function. It undoes what the original function does. So like, for example, if I want to go, let's say I set this equal to x, like I'm solving for x, right? The way this, could be shown is if I took the sine of each side of this equation, I'll be taking the sine of the arc sine of -1/2. And that would be, equal to the sine of x. But if I have the sine of the arc sine or the sine of the inverse sine, those undo each other. So all I'm left with on the left is -1/2. is equal to the sine of x. And that's essentially what we have here. So you want to basically just think what x value makes this equation true. Like the sine of what value is equal to negative 1/2. And it's just going to come down to you know, having your unit circle memorized, because that would just be negative pi over 6 or 1/6 pi, or negative pi or negative 1/6 pi. All right, so for B, if I want to find the arc cosine of 0, I essentially want to solve the equation the cosine of x is equal to 0. Like the cosine of what number is equal to 0? So again, making sure you have your unit circle down, x would just be equal to pi over 2, because the cosine of pi over 2 is 0. Next one, I have the arctangent of root 3. I want to essentially solve this equation. The tangent of x is equal to root 3. So I'm like, I have to figure out the tangent of what value is equal to root 3. Now, like everything in math, like the more you practice it, the more it just becomes like it's something you don't have to think about. But to kind of just break this down, if you're like wondering, like there's no like sine value or cosine value or tangent value that's, you know, root 3. Well, there is if you can think about how to simplify it. So let's first start off. We know that the tangent of x is equal to the sine of x over the cosine of x. So I'm thinking I basically have to think the sine of what value over the cosine of that same value equals root 3. And that would be pi over 3. X would be pi over 3. And that's because the sine of pi over 3 is root 3 over 2. And the cosine of pi over 3 is 1/2. And that just becomes root 3 over 1. Once you practice this stuff a lot, it just, you know, it just becomes second nature. It's not something you even have to think about. All right, and the last one, the arc sine of 0.3. This is just an example of where you'll need your calculator. And you can simply solve for it, because you're not gonna have every point memorized on the unit circle. It's, you know, that's impossible. So let's look at our calculator. See, we have this inverse sine, or the sine with like that -1. So I take the inverse sine of 0.3, and I would get about 0.30469. Now, also side note, make sure your mode is in radians. Like, unless it says in the problem, always assume that when dealing with trig functions, that your units are radians, not degrees. Okay, so now let's go over how a couple more equations where you're now solving, you know, for a value for x, and you're given, you know, you're given the angle. So again, we want to recognize that you can undo a function by taking the inverse of that function. So you can undo arctangent of something by taking the tangent of that something. So we would take the tangent of each side, the tangent, because the tangent of the arctangent of 2x minus 3, that would be equal to the tangent of pi over 4. So when you take the tangent of the arctangent, those cancel each other out. And you would just have 2x minus 3 on the left, I mean. And then the tangent of pi over 4 would just be 1, because the sine of pi over 4 over the cosine of pi over 4, they're both equal, so you'd get 1. And then all you have to solve is this simple equation. So you'd have 2x equals 4, and then x would be 2.